We're going to talk about using chords, tangents, and secants to find measures of angles and arcs. So we have a couple of theorems. This is not by any means all of the theorems, but these are the three that we're going to talk about, and then one as we progress. So first we have the chord theorem. So you can see in here we have the chord. A chord goes from one point through to the other side. We know a diameter can also be a chord. It does not go past it, and notice that these cross. So we have an angle of x. So the way that we think about this is the value of that x is the big arc, which we have the major arc there in green, and the smaller arc in blue, added together, and then half of that will be that angle. We could also find the angle that is there because they would be vertical. Then we know that these are straight lines, so then this angle and this angle have to equal 180. Same with this angle and this angle have to equal 180. So then you start, once you find one thing, you can find all the others. So that's one of our theorems. The second theorem is the tangent secant theorem. So notice we have a tangent in purple. A tangent goes along and hits at one point along the circle. So it's hitting at this one point only, and that's the point of tangency. And then we have a secant. A secant is very similar to what people think is a chord. However, it goes through, it intersects through, it doesn't just touch. It actually goes through and continues. It can continue on one side or both sides, but it's not just stopping like a chord. So on this one, we have a secant and we have a tangent, and then we have the angle that was made outside of the circle, and that is angle x. So to be able to find that angle, we actually take the major arc and subtract the minor arc. So before in the chords we added, this we're subtracting major, take away minor, so big minus small, and then half of that is going to give us that angle. We'll talk a little bit about tangent as we move on, but there is a tangent. Then we have secant. So we have these two red lines. You can see that they're secants. They go through the circle and continue, and we've created this angle outside. So to find that angle, if we know the major arc and the minor arc, we actually subtract the minor from the major, and it's half of that. So when we have the tangent secant and the secant, they are exactly the same as far as their formulas or their relationships. So we're going to do some examples. Example 1. First, I want you to look and see what is happening here. What do I have? Well, I can see that I have a tangent. It's hitting in one spot. And I also have a secant. And the secant is hitting, going through, and we have an outside angle. So I'm going to go ahead and write. This is, first I want to know what I'm doing. So this is a tangent, secant. And that's the theorem we're going to use. And if you look back up, a tangent secant is finding the angle, which is our x that we're trying to find. So the measure of angle x is going to be equal to half of the major arc minus the minor. And we're going to plug in those values. All right, so we're still looking for our angle. Our major is the 141, that's the bigger one, minus the smaller one of 61. Then you can use your calculator and you would see that x is equal to 40 degrees. For number 2, first we're going to look to see what we have. Well, we have a tangent right here. It's hitting at one spot. And we have a secant. So this again is a tangent secant theorem. Which means the measure of angle x is equal to half of the major arc minus the minor arc. Now we're going to plug in what we know. We know our major is right here, but we don't have it told to us, so we've got to figure out what that is. Well, if we know that a whole circle is 360, and we already have down here this 110, so from here to here is 110, here to here, and we know that from here to here is 70, that means 110 plus 70 gives us 180, and the whole circle is 360. Well, then we know from here, let's do another color, from here to here is 180. So now we know the major. So we have measure of angle X is equal to 1/2 the major, subtract the minor, so we get 1/2 of 110, and we end up with the measure of angle X equals 55 degrees. Let's look at number 3. Number 3 has a tangent. So we have a tangent going through right on the side. Use a different color here. So we have this tangent right here. We have another tangent right here. And this is something we haven't talked about yet, but we're going to talk about it now. So when we have two tangent lines, we also in this also have a circumscribed angle. So the angle's on the outside right here. And then we have a angle inside, an inscribed angle, which is this 58 degrees. So that will help us find some other pieces, because all right now we have is that. So we're going to use some prior knowledge. So we're going to actually talk and make a note for ourselves. This is two tangent lines. And we have a circumscribed angle. All right, so we're going to think about what we got to find. So if we think about the two tangent lines, very similar to the tangent and secant and the secant, we are actually going to find and use the measure of the angle is equal to 1/2 the major minus the minor arc. And when you do arcs, you put the little symbol over top. All right, so let's talk about first, let's find the minor and the major arc, because we don't know them. If we look here at our minor here, we know that we take that and we multiply it by 2, okay, because it's double whatever we're going to have. So we're going to have 58 doubled, which gives us 116. This is 116. Okay, and now once we know this, if we look about the major, so from here to here, we know that to find that, we're going to take 360 minus 116, and we end up with 244. So then this is 244. So if we use our formula, we could say the measure of angle X is equal to 1/2 of the major, which is 244, minus 116. Measure of angle X is 64 degrees. Now I want to talk about something, because there's another kind of rule that we need to know. So we found first the minor, the 116, using the inscribed angle. And so we already knew that. Another relationship that you need to know is that when you have two tangents, so a tangent, and the outside angle and this minor arc that first happens at 116, together they have to equal 180. Okay, so if you know that this is 116, 180 minus 116 will also give you 64. For number 4, we have a tangent. We also have a secant. So we know that this is going to be a tangent, secant theorem. So when we talk about this tangent secant theorem, we know that the measure of an angle is equal to 1/2 times the major, the minor. Now we're talking about this angle that is out here on the outside, that is made up by this tangent and secant. So we already know the measurement angle. What it's asking us to find is this x over here. So we've got to find some other pieces to be able to know. So this x, if we look at it in a different way, from here to here, this would help us with this angle here. That gives us an inscribed angle. So we don't know what it is, so we have to use our prior knowledge to find out what we do know. So what we're going to do is we're going to plug in what we do know. We know the outside angle is 35. We know that the major arc that's made up with this tangent and secant is 160, but we do not know the minor. So 160 minus 90, I know that my question mark is 90 degrees, okay? So that means this minor right here is 90 degrees, okay? So if I know that that is 90 degrees, and I know this is a angle here that is inscribed, and the relationship between this arc that it intersects and our angle, it's half of that. So then we know that x equals 45 degrees. For number 5, we have two chords. We have a chord here and a chord here. And we are trying to find the x value. So we're going to use the chord theorem. So we're looking at the arcs that are kind of across from this x, okay? If we had something here, like something here, we could use these, okay, to find it. So we're using the ones across. So we know that the measure of angle x is going to be half of 65 plus 75. So we would get the measure of angle x, after using your calculator, is 70 degrees. Number 6, we have a secant and a secant. So notice that this goes through both sides, and so it's not just hitting one spot, it's not a tangent, and through both sides, and we've got this angle out here on the outside. So this is a secant, and so measure of angle x is going to be equal to half of the major, which is 150, and the minor is 70, and when we do our math, we get the measure of angle x is 40 degrees. All right, I want you to try 7, 8, and 9. Pause the video and then check your work. So here's number 7. We had an inscribed angle, which helped us find the arc of BA, which then in turn, because we know that the whole circle is 360, we can then find x, which is 260. We did have a chord and a tangent there, but there is no formula for that. We use the inscribed angle for that. On number 8, we had the chord theorem, and then we had to plug in what we knew. We already knew the angle was 53 degrees, and then so we had to then combine our expressions, and we've got x is 9. On number 9, it's a tangent secant theorem, and we had to take the big one, which is the 4x minus 5, and take away the small of 50 to find the x. I did multiply by the 2 to get rid of the half. That's where we got the 2x. And then solve. So we've gotten 55 divided by 2, which is 27.5 degrees for x. The other thing we're going to talk about is cyclic quadrilaterals. This is when a quadrilateral has been wrapped or is embedded or inscribed inside of a circle. So notice that all of its vertices are on the circumference of the circle. And then the thing that you have to know is that opposite angles add up to 180 degrees. And then the exterior angle, if it extends out past that little piece of E, is the same as its opposing interior angle, which is a prior theorem that you should have learned about before with triangles. So this is something that you need to know. You'll see and be able to identify the relationships and what their values are.